Hello, everyone. Welcome to Spark NLP Healthcare Summit. Actually, this is Healthcare NLP Summit presented by Johnson Controls. This is Veysel, Head of Data Science Healthcare NLP team at Johnson Controls. Today, in this talk, I'm going to cover the current state-of-the-art accuracy for key medical NLP benchmarks that produce and ship in Spark NLP library with all the great people at Johnson Controls. So Spark NLP for Healthcare is an extension of Spark NLP open source project. So it extends everything from the open source. As you know, Spark NLP open source project is a highly popular and only scalable NLP library out there, which is downloaded more than 2 million every week. So Spark NLP for Healthcare extends everything from the open source and aims to provide accurate, which is always assuring the best accuracy in the academia and by using the latest state-of-the-art techniques. It's also scalable, which is actually this is the only scalable NLP library because it is sitting on the shoulder of Apache Spark itself, right? It is private, which means that you can ship this library in your environment with no internet connection and behind the firewalls in high compliant environments with no additional requirements rather than Spark itself. And it's tunable, which means that you can fine-tune this library with your own data, all this model that we ship right now. By the way, we have more than 600 pre-trained models just for the healthcare, just from the healthcare models, because in Spark NLP, we have more than 5,000 pre-trained models, and in just Spark NLP for Healthcare, we have more than 600 pre-trained models, including name identity recognition, clinical entity linking, assertion status, and relation extraction models. So it's also modular, which means that you can connect the dots and then build customized solutions by using all these pre-trained models, by using all the other modular annotator that we develop and ship within the library. So every clinical node, actually, when it comes to NLP in healthcare, the most minimal chunk is named entities. We call it clinical named entities. So clinical named entities feeds all the other downstream tasks that you might need to use in your workflow. For example, you may want to extract the clinical findings or conditions from your clinical talks, from your clinical text. Let's say that you want to analyze the radiology reports written by the radiologist. So you can extract the clinical findings from that radiology report and then send this output to the other downstream tests. Let's say that you want to also assign CPT code, right? So you need to use entity resolution for CPT. And so you feed the entity to resolver and it assigns CPT code. Then you also want to find out the negativity scope or of this entity, so that you feed this entity to the assertion status so that it assigns if it's happened before, if it's conditional, or if it is family related entities. Or you may want to find the sensitive information and then they identify by using the de-identification model. Then NER is needed over there because you need to use the de-identification NER model to extract sensitive information and then feed the de-identification model. And last but not least, relation extraction model to find the relationship between the clinical entities so that you can connect the dots while trying to solve your problem. So at the end of the day, this is the ideal situation, actually. So given your unstructured, noisy text, you would probably want to extract as many useful information as possible for certain purposes. Let's say you may want to tabular, you may want to extract some tabulated data from your unstructured text data, or you may want to solve some problems by using machine learning. So you may need some features that you may not get from the text by using other conventional techniques, right? So, or you may want to extract all this hidden information from text, let's say age, gender, or drug information, and then assign entity names for each valuable information out there, and then also feed these entities to other downstream text to find, let's say, risk adjustment score, or assigning Snowman or Aris norm codes to the drug entities that you that you might want to extract and report in another format. So that is the ideal situation to be able to achieve this visual, this extraction, this abstraction, let's call it. You need to use all these pre-trained models that we ship within the Spark NLP for Healthcare library without training anything at all, unless you really need it, with one line or two line of code at most. So the purpose of this talk, right, is to compare the accuracy key benchmarks of our models across the other popular APIs or solutions. Right now, of course, we are not the only library that are providing that is providing the clinical NLP solutions out there. But when it comes to publicly shared information for all these solutions, we only have like pay-as-you-go solutions provided by major cloud providers like AWS, Google, and Azure. There are many other players in this game, but they are all highly customized solution developed and shipped within certain products maintained by other companies. So we are not aware of their accuracies unless they publish this with some papers or white papers. So in this talk, we are going to compare our solutions, namely entity recognition and entity resolution, with all the other three different cloud providers, AWS, namely AWS, Google, and Azure. So we are going to cover clinical NLP solutions, pay-as-you-go solutions provided by AWS, which is called AWS Medical Comprehend. The other one is provided by Microsoft with the name of Text Analytics. And then the third one is GCP, Google Cloud platform, which is called Healthcare API. So they are more or less doing the same. Actually, the only difference is the name, is the granularity of the entities that they provide. You basically subscribe to their services, you send your data, and then they return a list of entities, relationships, entity resolution codes within a JSON format. So you use this information and then integrate into your application. You send your data to the cloud, by the way, but they are HIPAA compliant, so you kind of trust, and then you send your data to send information to cloud. But in Spark NLP, right, you don't need to do this because you can ship the same model, same accurate model, same combination within your own environment with no internet connection. So let's compare how we are doing against all these big major cloud providers. Since we are going to start with named entity recognition models, let me tell you a little bit about our basic fundamentals regarding named entity recognition models that we ship within the library. So we use two main approaches, actually. The first one is the most popular approach, which is widely used by all the other products or highly cited in other academic papers, which is called by LSTM CNN char architecture. So which means that we extract information, we extract features from text, because NER is already a token classification problem. So we try to assign label per token given the context, right? So we extract information from each token by using transfer learning, word embeddings, some features that we get from token like uppercase, lowercase, etc., and even the ladders. So we call it by LSTM CNN char architecture. Most of the pre-trained NER models, we are, by the way, more than 100 pre-trained NER models out there in the same library. So most of them are trained with this lightweight, highly accurate algorithm. We also, second way of doing this is replacing the glow embeddings, word embeddings with the BERT embeddings, like transformer architecture. So we use the same architecture again. And then the third one is well-known BERT for token classification model that you might see from the other transformer-based libraries. So in sum, we have more than 100 pre-trained NER models shipped within the library, and you plug and play any NER model with the same notation. You just change the name of the NER model, and there are also some helper function we provide to find the best NER model given your text. And out of more than 600 pre-trained models, 20% of this are all named entity recognition models. So in this slide, you see the entities provided, like returned by all the other cloud providers. For example, Google returns problem entity, Azure call it diagnosis, symptom, and allergen, like three different entities that you might consider under the problem entities. Let's call it clinical condition entity, and AWS call it clinical condition, sign, and symptom. When it comes to Spark NLP, we have more granularity because we provide more than 20 different entities just to explain condition, which means that you just don't get problem entities as a result. You get the most granular version of that problem, because it would be heart disease, it would be like a diabetes, it would be kidney disease, etc. Right? So rather than getting a one rough entity, you get a much granular version of the same entity, or if you want, you can just group by all and you can still return problem entities, right? So for example, for the test entity, AWS say it is test name. This is the name of the entity that you get within the JSON when you send your text. Azure call it examination name, but Spark NLP again return much granular version of the same entity, which is, it could be test result, imaging techniques, temperature, weight, etc. Right, like test and test results. So rather than being okay with only one entity or two entity, we return the granular version so that you can merge later on if you want, or you can, because we have different annotators inside the Spark NLP library that you can treat each entity given its type in the downstream test. For example, you can connect the test entity to another annotator that would return CPT code for the test entity, while you can send the problem entities to ICD-10 resolver that you end up with ICD-10 codes within the same pipeline without without letting the data go out of the pipeline. Okay, so if we compare one to one, right, AWS, Azure, Google versus Spark NLP, on the right hand side in the word cloud, as you can see, we provide more than 400 entities out of 100 NER models. You can barely see the entities that I try to visualize a little bit, which means that there are more than 400 entities, clinical entities, in much granular version. Let's say that you are working on the oncology domain, we have a specific and NER models just for working best on oncology related text. Or let's say you are trying to find the relationship between gene and protein, we have specific NER and relation extraction model that could help you to accomplish this goal. On the left hand side, as you see, you only be okay with whatever you are given, because you don't have a chance to customize this output. You feed your text and it just returns the results with these entity names. So how did we run the benchmark? Because I'm going to cover the benchmarks right now. So the goal is to show how well Spark NLP is doing compared to all the other solutions. As you can see, we have different granularities, so we group them by together and then try to compare apple and apple, right? So that we could have a fair comparison. So there is a website, because it's hard to gather clinical notes, right? Free text clinical notes text, but there is a well-known website out there which is called emptysamples.com. They provide 5,000 free text clinical note from 40 different domain, like as you can see on the right hand side. Dentistry 27 documents, dermatology 30 different documents, neurology more than 200 documents, which means that this website can be used for experimental purposes to extract some data, annotate, and train models. So what we did is we extracted 8,000 sentences from this website and then made sure that we selected a few NER models, like the major NER models that we have. We have some popular NER models that we trained internally by using internal annotators like NER GSL, NER radiology, etc. We made sure that in their training set, none of these 8K sentences appear, because we want to have a fair comparison, right? So we discarded all the sentences that might appear, because this is a popular NER, this is a popular website that so many other people might have used. So, but we wanted to make sure that we didn't use any of these 8,000 sentences, and then train the new models without using all these sentences. Then then compare the metrics. Okay, so the first comparison is Johnson Outliers, like Spark NLP for healthcare versus Azure. So we have 5 entity types that is returned like a. I just try to we just try to get the intersection of both libraries, right? When it comes to Azure versus Spark NLP, 5 category overlaps each other. So we use these 5 categories to compare each other. For the other cloud providers, we use other entity types, but most of the time you will see this 4 or 5 entities, similar entities. So as you can see, when it comes to test entities, Spark NLP is 7% better than Azure. Actually, it's almost 100% accurate when it comes to test and test result entities, while Azure returns to 92. So 7% means that when you do the math, it's almost like making 7% less errors. Spark NLP makes 7% less errors, or make less than 7 times, like makes errors less than 7 times compared to Azure. So when you compare with, for example, medication, the difference is highly obvious, by the way, highly clear. So we have 17% difference between Azure and Spark NLP. So, and you see the chart for anatomy and condition as well. So in overall, we are like Spark NLP for healthcare is overally 12% better than, which is making 12 times less error compared to Azure itself. So let's do the same for AWS. So when we compare the same entities by adding one more entity type, which is called procedure, because AWS also return procedure, but Azure doesn't. So we added the procedure entity as well, and then calculated the metrics. As you can see, we are, for example, almost 20% better in treatment entity when it comes to AWS. And we are, again, more than 25% better when it comes to medication. So overall, we are almost 19% better than AWS, which means that Spark NLP makes 19 times less error, right? So let's say AWS makes 19 times more error than Spark NLP can do on your clinical text. Because we are not just okay with the entities we have, right? Because we have more opportunity and more option to select, right? We have more than 100 NER models that we can chain together to find the most granular, or by checking their confidence scores, etc. There are some techniques that we cover in the notebooks that you find the right entity given your domain. So that because in machine learning, right, these are highly domain specific techniques. It's almost impossible to have a one single model that would rule them all. But we try to make sure that we cover as much domain as possible with less training. So when we compare Spark NLP with GCP, which is Google Cloud Platform, as you can see, the difference is when it comes to treatment is 20%. When it comes to test is around 18% as well. And when it comes to anatomy, like the body parts, right, it's more than 13%. So overall, we are 15% better than Google Healthcare API. So let's see the picture at once, right? When compare Spark NLP and all the other cloud providers in one single slide, because when we do the overlapping 4 entity types maps right now. So when it comes to treatment, you see on the left-hand side, it is treatment. The blue bar is Spark NLP, orange is AWS, and green is Azure, and gray is GCP. As you can see, in every domain, in every entity types, Spark NLP is almost 10 times better than all the others. So the next, then we didn't stop there. Of course, we try to see how well we are doing when it comes to the identification. So the identification is there to find the sensitive information and then replace or mask them, so that you keep the anonymization, you keep the sensitivity of your data, you anonymize your data while sharing with the other third parties. So in Spark NLP for healthcare, we support 5 different languages for the identification purposes, which means that you even like if you have clinical text from English, German, French, Spanish, Italian, which are the major languages, spoken languages, we support all of them out of the box, and then out of sub-entity, which means like 13 entities. So we can mask 13 different entity types from 5 different spoken languages. And then the metrics, as you can see, is mostly like above 95% when it comes to major entities that you need to de-identify. So when we do the comparison with state-of-the-art accuracy published by the papers, there is no state-of-the-art accuracy for German, Spanish, etc. But when it comes to English, of course, it's a popular language. We did the same benchmark by using their official data set. We train on the train set and tested on the test set that are used by 2014 IQB2 data set. And Spark NLP is 90% F1, micro F1, and then the latest state-of-the-art paper reports 87%, which is 3% less than what we already have. So if we check all the comparison with if we compare the languages across each other, this chart would visualize all of this. And let's just jump into the resolution, right? Resolves, because we are running out of time. Resolution means that returning ICD, CPT, Ariston, like we have 10 different entity resolution models out there. So let's do the comparison at first. So top one, like matching the top one result, we are almost 10% better than the closest competitor, which is AWS. So when it comes to Ariston, by the way, for Ariston, Spark NLP is leading right now in top 1 and top 5 compared to others. And Snowman, when it comes to Snowman, we are all AWS is doing really well here. But when it comes to top 5 and top 1, so it's almost same, Spark NLP and AWS, but GCP and Azure is way behind in this league. So ICD-10, when it comes to ICD-10 medical terminologies, assigning ICD-10 codes for the disorders, Spark NLP is leading with high margin. Its closest competitor is AWS, and we are almost 15% better than AWS. And in the top 5, it is more than actually again 10%. So when we do the digit sensitivity, like 2% versus like 2-digit versus 3-digit, because much, as I said, we have multiple versions of the same resolver. So in Spark NLP, you can also have 3-digit sensitivity, 7-digit sensitivity. So increasing the sensitivity also decreases the accuracy, right? So right now, Spark NLP for healthcare in the 3-digit sensitivity, we have 95% accuracy compared to 87 from AWS, which is the closest rival. And GCP and Azure, surprisingly, doing really worse when it comes to entity resolution, not just ICD-10, but for all other terminologies. So if we summarize these findings, Ariston, Snowman, and ICD, Spark NLP is doing better in Ariston and ICD-10, as you can see on the slide. In Snowman, AWS and Spark NLP is very close to each other, but Azure and GCP is highly behind in this race. We tried to cover all the metrics like NER and entity resolution metrics in this talk. I hope you enjoyed the summit. Please reach out to us if you have any questions. Thank you.